Hello there, and welcome back to Sleep Lab Science. If you're settling into bed, finding a soft rhythm in your breath, this is your moment to rest. Tonight, we're going to drift into one of the most mysterious stories the universe has ever whispered, a story about why anything exists at all. So, take a slow breath, let your shoulders soften, and imagine the early universe, not as stars or galaxies, but as a glowing ocean of energy, a hot, trembling haze where particles flickered into being like tiny sparks and vanished just as quickly. In that first fraction of a second, the cosmos wasn't quiet the way it is now. It was wild, chaotic, overflowing with equal parts matter and antimatter, locked in a perfect but fragile balance. Every particle had a twin, a mirror self made of opposite charge. Whenever they met, they disappeared together in a flash of light. If the universe had stayed perfectly symmetrical, nothing solid would have survived. No atoms, no stars, no galaxies, no life, just endless light. And yet, something broke the symmetry. Something so small, one extra particle of matter for every billion particles of antimatter, that it seems almost like a cosmic accident. But that one in a billion imbalance is the reason you can breathe, the reason planets can form, the reason the night sky holds shape instead of dissolving into glare. Scientists call this puzzle baryogenesis, the moment the universe quietly chose matter over antimatter. But the why behind it remains one of the softest, most elusive mysteries in physics. Maybe it began as a kind of cosmic phase change, like water turning to ice. Maybe the universe fractured into regions with slightly different rules. Maybe hidden fields from the inflationary era nudged matter into dominance. Maybe the laws of physics themselves are only local truths, one set of rules inside our bubble of space, and very different rules in others. Because beyond our cosmic horizon, there might be more. Other regions, other universes, other versions of physics, some calm, some chaotic, some sterile, some bursting with strange forms of matter we can only dream about. Tonight, we'll drift gently into these questions, not to solve them, but to feel their quiet wonder. Why is there something instead of nothing? Why did matter win? And what lies beyond the edges of the universe we can see? As you relax deeper into the dark, let these mysteries become soft shapes in your mind, not demanding, not urgent, simply floating like distant galaxies across the quiet sky. Whenever you're ready, we'll begin. Part I, the first quiet drift into the galaxy. Settle in, let your shoulders soften, and imagine the world growing quiet around you, like a blanket being lowered over the sky. Tonight, we open the first doorway into an ancient, shimmering realm, the Andromeda Galaxy, our cosmic neighbor, our celestial companion, and the largest spiral system drifting toward us across the vast dark sea of space. This first chapter unfolds slowly, like the rising glow of a distant sunrise, helping your mind wander effortlessly into a calmer, dream-soaked place. So take a long, unhurried breath, feel your thoughts soften into a gentle drift, and let's begin. 1. A soft introduction. Meeting a neighbor across the night. When you step outside at night and look up into the quiet sky, the stars you see glimmer like tiny memories of ancient light. But if you let your eyes settle into the darkness, not searching, not straining, simply allowing the night to hold you, you might notice a faint, ghost-like smear resting in the constellation of Andromeda. To many throughout history, it looked like a wisp of milk or a tiny cloud caught on the edge of the world. But this soft little blur is not a star, not a planet, and not a cloud made of earthly vapor. It is an entire galaxy, a colossal spiral of over 1 trillion stars, floating more than 2.5 million light-years away. Imagine that. The softest, faintest glow your eyes can barely capture is actually the combined light of 1 trillion suns drifting across the cosmos for millions of years before finally reaching you. Even the thought of it brings a sense of quiet wonder, a reminder of how enormous the universe is, and yet how gentle it can feel in moments like these. 2. A slow drift through time. Before we go deeper, let your mind loosen with the rhythm of deep space. In this first chapter, we move slowly as light, traveling across the cold expanse of the universe, so your thoughts align with the natural pace of the cosmos. The Andromeda Galaxy has existed for billions of years, long before any human ever looked up and wondered. It was here before mountains rose, before oceans formed, before life sprouted from the Earth's warm cradle. And as we begin this calm exploration, imagine Andromeda not as a distant scientific object, but as a quiet, ancient presence, watching the universe change one peaceful moment at a time. Its arms turn, but they turn slowly, so slowly that a full rotation takes nearly 1 billion years. Its stars pulse and burn, but they burn steadily, calmly, eternally. There is no rush in the galaxy, no urgency, only the serene unfolding of cosmic time. Let yourself match that tempo. Slow, gentle, timeless. 3. The shape of stillness. Andromeda's spiral arms. Picture a giant whirlpool of starlight, drifting through space like a silent hurricane made of glowing particles. That is Andromeda, a grand designed spiral galaxy, with arms that sweep outward like ribbons of mist, each one shimmering with suns, clusters, star nurseries, and delicate tendrils of cosmic dust. These spiral arms are not fixed or rigid. They move like slow twisting silk, shaped by gravitational waves that ripple across the galaxy's disk. If you could hover above Andromeda and watch its structure in a time-lapse spanning millions of years, you would see the arms breathing, stretching, curling, uncurling, shifting, like the gentle tides of a cosmic ocean. The stars in these arms travel together in broad, sweeping currents, drifting around the center like leaves caught in a slow, endless eddy. And all of it happens in silence. A silence so complete it could cradle your mind until sleep drifts in like a tide. 4. The heart of the galaxy. A quiet, massive core. At the center of Andromeda lies a supermassive black hole, quietly shaping the galaxy around it. Despite its intimidating name, imagine it not as a violent monster, but as a still, dark anchor, a point of absolute calm, around which trillions of stars glide in ancient orbits. The heart of Andromeda is brighter than its surroundings. Packed tightly with older stars, it glows like a warm ember, as if the galaxy carries a secret fire deep inside. This core has witnessed the birth of countless stars and the slow fading of others. It has seen nearby dwarf galaxies drift too close and dissolve into its halo. It has even shaped the long story of space between Andromeda and the Milky Way. And yet, it glows with a steady, patient light. Nothing hurried, nothing loud. Just the peaceful pulse of a galaxy that has existed since the earliest chapters of time. When you imagine this glowing heart, try picturing it the way the universe itself might see it, not as a threat, not as a mystery, but as a quiet center of gravity, the still point around which beauty forms. 5. The halo. A soft shell of ghost stars. Surrounding the visible arms is a vast, diffuse halo of ancient stars. These stars are faint, fragile, and incredibly old, some among the oldest in the universe. They drift in quiet, elliptical orbits, spaced so far apart that each star could wander for millions of years without ever meeting another. This halo is like a pale mist around the galaxy, almost invisible, but full of cosmic history. Think of it like the afterglow of memory, soft, airy, drifting. Andromeda's halo stretches far beyond what you can see, spanning hundreds of thousands of light years. In its ghostly glow lie remnants of galaxies that Andromeda has absorbed over billions of years. Their stars still wander the outskirts, like echoes of ancient visitors. It's strange to think about, but every galaxy you see today is built from the remnants of countless earlier galaxies, long-vanished civilizations of starlight that came together to form something larger, quieter, and more beautiful. Andromeda carries those memories in its halo, like a gentle whisper. 6. Star nurseries, cradles of quiet light. Deep within Andromeda's spiral arms lie enormous nebulae, clouds of gas and dust illuminated by the newborn stars forming within them. These are the star nurseries, glowing with soft pink and deep red light, like lanterns floating in a cosmic fog. Inside these clouds, gravity slowly gathers particles together until they ignite into brilliant new suns. Some will live for billions of years, others will shine fiercely and fade quickly. But in their earliest moments, they burst into existence as gentle orbs of warmth and light. If we could drift through these nurseries, the view would be breathtaking. Waves of color, drifting dust, distant glimmers of baby stars shining through their cradles of gas. Everything would move slowly, drifting, shimmering, like a dreamscape made of soft light. These nurseries remind us that the galaxy is constantly renewing itself. Even in the farthest reaches of the universe, creation unfolds in quiet, patient cycles. 7. The space between. A calm, infinite silence. Between the stars, between the arms, between everything that glows. There is darkness, but this darkness is not empty. It is soft, serene, almost tender, a vast ocean of calm that stretches from star to star, planet to planet, galaxy to galaxy. In this dark space, radiation hums faintly, particles drift lazily, and the quiet fabric of space-time curves gently under the influence of gravity. The silence is so profound, so absolute, that it almost feels like the universe is holding its breath. As your mind drifts through this cosmic quiet, feel your own thoughts soften to match its pace. Slow, gentle, drifting, like dust moving through starlight. 8. A peaceful perspective. As this first chapter draws to a soft close, remember that Andromeda, with all its stars, all its mysteries, all its swirling arms and glowing nurseries, is only one galaxy among trillions. And yet, for tonight, it is our companion, a gentle guide, a slow, glowing presence in the distance. In the next chapters, we'll drift deeper into its structure, explore its stars, wander through its dust lanes, meet its ancient clusters, and follow the long, slow story of how it formed, and how it will one day meet our own Milky Way. But for now, allow the softness of this vast spiral system to wrap around your thoughts like a warm night breeze. Let the galaxy breathe you into stillness. Let the stars lighten your mind. Let the quiet settle in your chest like a calm tide. And when you're ready, we'll continue our journey deeper into the heart of Andromeda. Part 2, drifting deeper into Andromeda's ancient light. As we continue our quiet cosmic journey, imagine yourself floating gently through the vast expanse between galaxies. The Milky Way lies behind you like a pale river of scattered light, and ahead, like a distant lantern glowing through the night, the Andromeda galaxy slowly expands into view. There is no sound in this place, no wind, no footsteps, no breath. Only the eternal stillness of the universe, a silence so deep it feels like a soft bed of velvet beneath your thoughts. And as you glide through this darkness, you begin to notice the delicate details of Andromeda revealing themselves, layer by slow, shimmering layer. Let's drift in a little closer, deeper, into the slow-turning currents of this ancient spiral. 1. A closer look at the spiral arms, highways of light. From a distance, Andromeda's arms appear like gentle swirls of smoke, but as you approach, they stretch out beneath you like vast highways of starlight, glowing bands filled with suns of every age, size, and temperature. Some stars gleam with icy blue brilliance, burning fast and bright, like sparks flickering on the edge of existence. Others glow a soft golden hue, gentle and steady, like the warm light of a lantern in the fog. And scattered throughout are ancient red stars that burn with a quiet, internal warmth like embers resting beneath layers of ash. The spiral arms are not simple structures. They are immense rivers of stars and dust that twist through space with graceful, slow arcs. and each arm is alive with activity, star formation, cloud collapse, stellar winds drifting like cosmic breezes. But the movement here is so slow, so steady, that even if you watched for 1,000,000 years, the arms would barely seem to shift. The galaxy moves in the rhythm of deep cosmic time, and in that rhythm, your own thoughts begin to slow, to unwind, to drift with the same effortless grace. 2. Dust lanes, the soft, shadowed veins of the galaxy. As you glide along one of these luminous arms, you might notice broad, dark streaks cutting through the light, delicate, shadowed lanes made of cosmic dust. These dust lanes are not empty. They are rich, fertile fields where stars are born. They contain the elements of everything: carbon, oxygen, iron, the building blocks of planets, oceans, and life. From afar, these lanes appear like thin brush strokes, as though the universe painted them with charcoal across a glowing canvas. But up close, they look like gentle clouds drifting through starlight, soft and velvety, hiding newborn stars inside their folds. The dust itself is made of tiny grains smaller than specks of smoke floating in the quiet vacuum of space. Together, trillions of these grains create structures that stretch for thousands of light years. If you trace your way along a dust lane, you'll see pockets of faint ruby-red glow, signatures of hydrogen clouds being energized by young stars inside. The dust hides the stars from view, but their light still leaks through in soft, muted tones. These clouds are the galaxy's wombs, cradling the next generation of suns. And in the gentle shelter of these dust lanes, the universe whispers a timeless truth. Creation is slow, patient, unhurried. 3. Star clusters, islands of light drifting in the dark. As you venture deeper into Andromeda, clusters of stars rise into view like islands, floating in a dark cosmic sea. Open clusters, the young and restless. Open clusters are loose gatherings of young stars, glowing bright and blue. They are born from the same cloud of gas and dust, siblings in the cosmic sense, still traveling close to one another in their early years. These clusters shine brightly against the darkness, like glimmering beads scattered across a black surface. Some contain only a few dozen stars, others hold thousands. In their youth, they glow with a radiant energy, as though eager to announce themselves to the quiet universe. But over millions of years, gravitational tides stretch them apart, and the stars drift away into the galaxy to begin their long, solitary journeys. Globular clusters, the ancient guardians. Much farther out, you encounter globular clusters, tightly bound spheres of hundreds of thousands of extremely old stars. They orbit the galaxy like ancient guardians, keeping silent watch over Andromeda's evolution. Globular clusters have existed almost as long as the universe itself. Their stars are old, red, faint, and steady, the slow-burning elders of the cosmos. Many of these stars formed more than 10 billion years ago, long before the spiral pattern of Andromeda even emerged. Approaching a globular cluster feels like watching a miniature galaxy, perfectly spherical, glowing with the calm resilience of age. Every star here has seen cosmic storms, galactic collisions, and the birth and death of countless generations of suns. Yet they remain together, bound by gravity, a family of light drifting through eternity. 4. The quiet mathematics of galactic motion. As we drift farther into Andromeda's interior, the stars appear to move in slow, elegant orbits. Every star, every cluster, every cloud traces a long, predictable path shaped by gravity. In a galaxy, nothing moves in a straight line. Everything curves, bows, responds to the pull of masses both near and far. Even the space between stars flows like an invisible river, guiding their motion across time. Imagine watching a single star orbit around the center. It could take hundreds of millions of years to complete one loop, a journey longer than the existence of the human species. Now imagine all 1 trillion stars moving in synchrony, each one tracing its own path. each orbit adding subtle ripples to the galaxy's grand design. This motion is slow, almost imperceptible, but when viewed on cosmic scales, it becomes a breathtaking ballet of light, a dance without music, without a stage, without an audience, and yet perfect in its silent grace. 5. The dual nucleus, a hidden secret at the core. As you drift closer to Andromeda's core, you begin to sense the gravitational pull strengthening, a soft tug, like a gentle current drawing you nearer. And here, deep in the heart of the galaxy, you uncover a fascinating structure, Andromeda's double nucleus. While it looks like a single bright point from Earth, in reality, the core contains two tight clusters of stars orbiting a central supermassive black hole. One cluster, called P1, is slightly offset, glowing like a warm, golden ember. The other, P2, sits closer to the black hole, bluer, brighter, and more compact. These two clusters whirl around each other like partners in an ancient, slow-motion dance. A dance that has lasted for millions of years, and will continue long after our galaxy and Andromeda merge. Despite being surrounded by intense gravity, the core feels strangely calm. The light is warm, golden, and steady. The motion is smooth, predictable, almost soothing. It is a reminder that even in the deepest, most complex regions of a galaxy, there is order, structure, and peace. 6. Andromeda's satellites, a family of companion galaxies. Beyond the glowing spiral arms, beyond the halo, scattered across the dark reaches of space, lies Andromeda's extended family, a collection of smaller satellite galaxies that orbit like quiet children around a luminous parent. Among them, the most famous are Messier 3, 2M, 32, a small, compact galaxy that orbits close to Andromeda's disk. It contains very old stars and has lost much of its outer structure, stripped away by Andromeda's tidal forces long ago. Today, it glows like a soft pearl near Andromeda's brighter core. Messier 110M, 110, larger than M32 but still modest compared to Andromeda. M110 is a faint, elliptical galaxy filled with ancient stars. It drifts peacefully in orbit, never straying too far, like a quiet companion walking alongside a giant. Dwarf spheroidals, dozens of tiny galaxies, each containing only a few million stars. They hover at the edge of Andromeda's halo like specks of dust floating in a sunbeam. These satellite galaxies are remnants of an earlier time, fragments of cosmic history, drifting quietly through the universe. Some may one day be absorbed into Andromeda, their stars added to the halo, like new whispers of ancient light. 7. The faint streams, ghostly rivers of stars. As you venture into Andromeda's outer halo, something beautiful becomes visible. Faint stellar streams, long ribbons of stars stretching across space like trails of soft, shimmering fabric. These streams are the remnants of smaller galaxies that Andromeda absorbed long ago. Their stars were stretched and torn apart by gravity, scattering into graceful arcs that wrap around the galaxy. Each stream is like a memory written across the sky, delicate, ancient, poetic. Some streams curve tightly around Andromeda, shining faintly like halos of frost. Others stretch far into the darkness, fading into obscurity, their origins lost to time. These streams remind us that galaxies grow not in violent bursts, but in long, slow cycles of merging, absorbing, and transforming. Growth in the universe is gentle, patient, almost tender. 8. The view from a distance, a cosmic lantern. As part 2 draws to a calm close, imagine yourself drifting outward from Andromeda, slowly rising above its glowing disk. The spiral arms shrink beneath you. The dust lanes merge into soft, dark streaks. The core becomes a bright, steady point, and soon, the entire galaxy appears as a glowing oval, soft at the edges, bright at the center, fading gently into space. It looks like a lantern floating in infinite darkness, silent, serene, beautiful. A galaxy made of 1,000,000,000,000 suns, each one burning quietly in the dark, each one sending its light across millions of years, just to exist in this single, peaceful moment. Let that image rest in your mind. Let it soften the thoughts in your chest. Let it slow your breathing. Part 3. Through the silent starfields of Andromeda, take another slow breath. Feel your body sink deeper into rest. And imagine the soft glow of Andromeda spreading quietly across your horizon. We've drifted through its spiral arms, wandered beneath its dust lanes, traced its rivers of stars and clusters. Now, in this next gentle chapter, we slip deeper into the subtle, ancient mechanisms that shaped this galaxy over billions of years. This is a journey through memory, through the quiet history written into each star, each cloud, each drifting ribbon of cosmic dust. Let yourself float unhurriedly, as if carried by the faint currents of starlight. 1. The cradle of origins. Before Andromeda was a spiral. Long before Andromeda became the grand, swirling galaxy we see today, it existed in a much simpler form. Not a majestic spiral, not a glowing cosmic whirlpool, but a dim, irregular cloud of gas and tiny new stars. Imagine looking back more than 10 billion years to a time when the universe was young. The first galaxies were chaotic, messy, uneven collections of matter slowly beginning to organize themselves under gravity. Andromeda was born in this era. It began as a gathering of small protogalactic clouds, diffuse, faint, barely held together. Over time, gravity pulled these clouds closer, merging them, shaping them, and stirring their contents like a cosmic pot. As they merged, turbulence swirled through the gas. Shock waves rippled outward. New stars ignited, lighting up the darkness like sparks in a vast night. Through countless gentle collisions and slow gravitational embraces, Andromeda began to flatten into a rotating disk. For millions of years, this disk turned quietly, organizing itself into lanes of dust and arcs of forming stars. And with each slow rotation cycles lasting hundreds of millions of years, the galaxy smoothed itself out, settling into the first hints of a spiral shape. This is how beauty forms in the universe. Not suddenly, but through patient, timeless cycles. 2. Accretion and mergers. The galaxy that became many. Galaxies grow by meeting one another, drifting close, and merging in long, slow dances. Not violent, not explosive, but soft, drawn-out interactions lasting hundreds of millions of years. Andromeda has grown through dozens of such encounters. Tiny galaxies wandered too near, were gently caught by Andromeda's gravity, and slowly pulled apart, their stars stretched into streams, their gas absorbed into the greater whole. Some left behind beautiful arcs of stars that still glow faintly today. Others disappeared completely, their remnants mixed into Andromeda's halo like ancient dust. These mergers enriched Andromeda with gas, dust, and new stars. They triggered waves of star formation. They helped sculpt the thick and thin disks, the bulge, the halo, every part of the galaxy layered like a geological timeline. Even the double nucleus at the center is likely the result of one such ancient encounter, a small galaxy swallowed long ago, its core settling permanently into orbit around the central black hole. Every faint stream, every cluster, every irregular patch of stars is a memory of those cosmic meetings, a reminder that galaxies are not solitary. They are social, interactive, always evolving. 3. Andromeda's disk, a slow-forming masterpiece. As you drift silently through the bright disk of Andromeda, the stars thicken around you like grains of glowing sand, billions of them, close enough to fill your field of view, yet separated by enormous distances. The disk is divided into layers, an inner region dense and bright, a middle zone rich with star nurseries, and an outer disk stretching out like a faint, delicate mist. The inner disk, warm and golden. Here, older stars dominate, yellow, red, soft, gentle in their glow. They orbit smoothly, following paths carved out by billions of years of rotation. The light is warm here, like candlelight filtering through soft fabric. The middle disk, where stars are born. Farther out, massive clouds of hydrogen swirl lazily through the spiral arms. These clouds collapse into clumps, forming newborn stars. Ultraviolet light from these young stars energizes the surrounding gas, causing it to glow pink and crimson. This region is alive, but in the slow, dreamy way the universe understands life. Waves of star formation drift across the disk for millions of years, like tides moving through a cosmic ocean. The outer disk, quiet and faint. In the far reaches, the stars become sparse and ancient. They shine weakly, like memories fading in the dark. Beyond them lies mostly emptiness, a whisper of starlight, the edge of a galaxy that spans more than 220,000 light-years. The disk is a record of everything Andromeda has experienced. Its inner regions tell of early formation. Its middle arms reflect ongoing creation. Its outer edges preserve the gentle remnants of long-ago mergers. All of it speaks the same quiet language of cosmic time. 4. The galactic halo, Andromeda's quiet outer shell. Beyond the disk lies a vast, spherical halo that extends far, far beyond what the eye can see. It is enormous, almost invisible, filled with ancient stars spaced so widely apart that you could travel for centuries without passing one. This halo is a treasure chest of cosmic archaeology. Ancient stars in the halo. Some stars here are older than Andromeda itself, leftovers from galaxies that were devoured billions of years ago. They drift quietly, following long elliptical orbits, shimmering like distant fireflies. Dark matter, the invisible sculptor. Most of the halo, however, is made of dark matter, mysterious, unseen, yet crucial. It forms the gravitational skeleton of the galaxy. Without it, Andromeda's stars would drift away into space. But because of dark matter, they stay together, orbiting steadily, forming the familiar spiral we see today. Dark matter is silent, weightless, invisible, but utterly essential, a quiet guardian holding the galaxy in a gentle embrace. Stellar streams in the halo. Here, too, we find the faint ribbons of stars, the remains of small galaxies pulled apart long ago. These streams arch across the halo like pale, ghostly rivers. If you float beside one, you would see stars spaced like beads on a necklace, drifting in a slow, endless curve. They are the whispered stories of Andromeda's past. 5. The giant stars, titans of the spiral. As you glide deeper into the star-filled regions, your attention is drawn to the largest, brightest, most powerful stars in Andromeda. Blue giants. Hot, massive, blazing with blue-white light. These stars live fast, burning through their fuel in just a few million years. They shine with a fierce brilliance. But even that brilliance feels soft and distant from this quiet vantage. Red supergiants. Enormous, cool, and glowing with dim crimson warmth. Some are hundreds of times larger than our sun, bloated into giant orbs of soft, reddish fire. If you could float near one, the star would fill your sky like a glowing horizon. Calm, steady, ancient, variable stars. Some stars pulse, gently brightening and dimming as they expand and contract. Their rhythms are slow, almost like breathing. A cosmic inhale, a cosmic exhale. These rhythms help astronomers measure distances, but in this moment, they simply add to the universe's quiet heartbeat. 6. The dying stars. Soft endings in the dark. Not all stars are young and bright. Many have reached the ends of their long lives and now drift into silence. White dwarfs. Small, faint, extremely dense. They glow like tiny embers, the leftover cores of stars that shed their outer layers. Planetary nebulae. When certain stars die, they release their outer shells in glowing waves of gas, forming delicate, circular clouds illuminated by the remaining core. These nebulae float like soft bubbles in space, thin, colorful, peaceful. Supernova remnants. Some stars end in magnificent explosions, scattering their elements across space. What remains afterward is a faint, expanding cloud of gas and dust, a soft, ghostly veil hanging in the galaxy. It is from these remnants that new stars form, creation from destruction, beginnings born from endings. This is one of the universe's most gentle truths. 7. The silent interstellar medium, the breath of the galaxy. Between stars, between clusters, between the glowing nebulae, lies a thin, almost imperceptible substance, the interstellar medium. It is made of hydrogen, helium, dust grains, and drifting particles. So thin that a cubic meter might contain only a few atoms, yet stretched across the galaxy, it becomes a powerful engine of change. This medium flows, slowly, like a river of invisible wind. It collects into dense regions. It stretches into filaments. It drifts into voids. It is the breath of Andromeda, a soft, unhurried circulation of gas and dust that feeds star formation and carries away the remains of dying suns. Floating within it feels like swimming in a gentle, cosmic ocean. 8. Rising above the disk. The galaxy unfolds beneath you. As Part 3 draws to a peaceful close, imagine yourself drifting slowly upward, leaving the star fields behind. The glowing disk spreads below you like a celestial sand dollar, broad, rounded, luminous. The spiral arms curl gracefully outward. The dust lanes appear like soft strokes of charcoal. The core glows like a warm ember, and around it all, the faint halo shimmers like a sphere of powdered light. In this position above the galaxy, looking down you see Andromeda not as a distant object, but as a living system, a breathing, evolving, shimmering presence in the dark. Let that image settle gently into your mind. Let it ease your thoughts. Let it quiet the world around you like a soft blanket. Soon, we'll continue to Part IV, drifting into the mysteries of planetary formation, deep interstellar structures, and the quiet future of Andromeda's long cosmic journey. Part 4. The Milky Way's quiet secrets. Take a moment. Let your shoulders fall with gravity's quiet pull, and allow your breath to drift gently in and out, like the soft rhythm of a tide in the dark. Because now, in this peaceful stretch of night, we continue our slow journey through the cosmic fields and wander deeper into the secret rhythms of our own galaxy, the Milky Way. Even though we live inside it, wrapped by its spiraling arms like tiny starglow seeds inside a vast cosmic flower, there are countless things about the Milky Way that we still barely understand. So tonight, let's walk through its mysteries together, softly, like strolling through a moonlit valley where every sound is hushed. 1. The silken spiral arms. Imagine, if you will, drifting outward from our sun, past the orbits of the planets, beyond the gentle halo of icy comets, and into the great spinning body of the galaxy. From within, the Milky Way doesn't look like a spiral. It feels more like a glowing fog, a soft, milky river streaming across the sky. But from above, if you could float miles above the galaxy on a quiet cosmic wind, you'd see long, elegant arms that spiral gracefully outward. They're not solid structures, not fixed like the spokes of a wheel. They're more like slow-moving waves of star formation patterns that drift through the galaxy the way ripples drift across a pond. Inside these arms, clouds of gas are gently squeezed, and inside those clouds, new stars begin to glow. It's as if the Milky Way inhales and exhales light, breathing stars into existence. If you could slip your hand through these arms, they wouldn't feel like anything at all, just emptiness sprinkled with unimaginable distances. A teaspoon of space here, a teaspoon of space there, empty, quiet, cold. And yet from that emptiness, entire suns are born. 2. A journey to the galactic core. Now let your mind drift inward, like sliding down a long, spiraling staircase toward the heart of the galaxy, all the way to the galactic center. It is not a bright, blazing core like many imagine. It is a region wrapped in clouds of dust so thick that ordinary light cannot pass through. From Earth, the center looks like a soft golden haze, tucked in the constellation Sagittarius. But behind that haze, something hums quietly in the dark, a supermassive black hole. Its name is Sagittarius A star, or Skra A asterisk. It sits at the center of our galaxy the way a pebble sits at the center of a whirlpool, calm at the center, while the world spins around it. You might think a black hole would be chaotic, violent, destructive, but our galaxy's central black hole is strangely calm. It whispers more than it roars. If you could drift near it safely, float just outside the region where time begins to fold into itself, you wouldn't hear anything at all. Just the sound of your own breath in your helmet. Slow, soft, steady. The stars around the black hole move like dancers in a slow-motion waltz, each one circling along curved paths carved by the hole's immense gravity. Some of these stars, like the famous star S2, race around the black hole at incredible speeds. But even so, when viewed from the quiet safety of distance, it looks peaceful, as if the galaxy itself is breathing around its core. 3. The halo you never see. Most people imagine the Milky Way as a flat, swirling disk. But in truth, it's wrapped in a vast, invisible halo, a ghostly sphere surrounding the galaxy like a faint dream. This halo isn't made of stars, at least not many. It's made mostly of something we cannot see or touch. Dark matter, a kind of cosmic scaffolding. Weight without substance, presence without light. It holds the galaxy together, keeping the stars bound in their orbits. Without this halo, the Milky Way would simply drift apart. You might imagine dark matter as a subtle breeze that flows through everything, but cannot be felt, or like the faint memory of a sound, still echoing even though the source has disappeared. And sprinkled throughout this ghostly halo are old, ancient clusters of stars, globular clusters, each one like a glowing lantern hanging in the darkness, each one containing hundreds of thousands of ancient suns, some almost as old as the universe itself. These clusters drift in slow, stately paths around the galaxy, like elderly guardians watching over the young stars in the spiral arms below. 4. Life. Inside a rotating disk of stars. Let's return now to the calm, rotating disk where our solar system resides. Our sun is tucked into one of the Milky Way's minor arms, the Orion Arm, a quiet, peaceful neighborhood far from the bustling galactic center. Here, stars are spaced so far apart that if the sun were the size of a basketball, the nearest star would be another basketball sitting in another country. And yet, even with all that space between them, the galaxy moves together in a slow, majestic rhythm. The entire Milky Way is rotating. Every star, including our sun, is completing a massive 230 million year orbit around the galactic center. One full sweep through the arms. One gentle journey through cosmic time. Since the dinosaurs vanished, Earth has traveled only a small fraction of this vast orbit. Your entire lifetime, no matter how long or short, is just a tiny sparkle along this long galactic path. And yet, that little sparkle matters, because you are part of this galaxy, made of its atoms, shaped by its stars, the calcium in your bones, the iron in your blood, the oxygen in your lungs. All of it was born in stars that lived and died inside this very galaxy. You are the Milky Way, dreaming of itself. 5. Gentle star nurseries. Now, let's slow down even more and wander through the Milky Way's quiet nurseries, places where new stars are born inside cool clouds of gas and dust. These clouds are so large that you could line up thousands of solar systems inside them. But inside this immensity, everything is quiet, slow, dark, and cold. Imagine drifting through such a cloud. There would be no sound, no wind, just darkness so rich that it feels like velvet. But deep inside the cloud, pockets of gas begin to gather, shrinking slowly under their own weight. As they collapse, they grow warm, and eventually, light begins to appear. First a soft glow, then a gentle shimmer, then a new star is born. The process takes millions of years. A patient rhythm, a cosmic lullaby. The Milky Way creates new stars, the way forests create new leaves, quietly, regularly, without hurry. Even now, as you listen, somewhere inside the galaxy, a new star is forming, and another is fading, and another is drifting into the cool arms of the halo. The galaxy is always changing, always breathing. 6. The river of stars above our heads. When you look up at the sky on a clear night, and you see that faint, milky band stretching overhead, that soft, glowing river, you are seeing the galaxy from the inside. Every speck of light is a distant star. Some are bright and close. Some are old and faint. Some may have planets like ours, orbiting calmly in the dark. And that milky band is only a tiny part of the whole, just the inner glow of the galactic disk, seen edge on. It's like looking at a forest from inside the trees. You see trunks and branches and leaves everywhere, but the true shape of the forest escapes you. We live inside a forest of stars, a forest so wide that even a beam of light takes 100,000 years to cross it. And yet, when we look up, it feels gentle, soft, comforting, a reminder that even in a vast universe, there is a place we call home. 7. A galaxy at peace. Despite its enormous size, despite the swirling arms, and the drifting clusters, and the quiet halo, the Milky Way is, at heart, a calm and peaceful place. Collisions between stars are incredibly rare. Violent events happen, yes, but they are not the norm. Most of the Milky Way's life is spent in quiet cycles. Stars forming, stars living, stars fading, stars returning their material to space. And through it all, the galaxy keeps spinning, softly, silently, like a great cosmic mobile turning in the dark. As you imagine this gentle rotation, let your breath follow the same rhythm, easy, slow, unhurried. The night is long, the stars are calm, and the universe is in no rush. Part 5. The gentle life and quiet death of stars. Settle in once more. Feel the weight of your body sink softly into where you rest, and let your breath drift out like a warm sigh across the night. Because in this next chapter of our quiet cosmic journey, we travel into one of the most peaceful and yet most profound rhythms within the Milky Way, the life cycle of stars. Not in a dramatic way, not in the fiery, explosive way that documentaries often portray, but in a slow-moving, dreamy way, the way the universe actually feels when we zoom out and listen to it breathe. Tonight, we'll wander through the long, gentle life of a star, from its slow beginnings as a whisper of gas, to its soft fading at the end, all in the calming, lullaby-like cadence of Sleep Lab science. 1. The quiet birth of a star. Stars do not begin with light. They do not begin with heat. They begin with cold. Very, very cold. Imagine drifting through a giant cloud of gas, a dark, velvety expanse, where temperatures hover just above absolute zero. Nothing stirs here. There is no breeze, no sound, no light, just stillness. Inside this stillness, gas begins to gather, slowly, gently, subtly drawn together by gravity, like tiny particles of dust settling at the bottom of a calm pond. You could watch this cloud for 1,000 years, and it would look exactly the same. Watch it for 1,000,000 years, and it would still look almost unchanged. Star formation is the slowest kind of magic, and yet, deep inside the cloud, something begins to warm. A soft glow begins to flicker. A tiny kernel of light forms, not yet a star, but a protostar, a seed of fire wrapped in a cocoon of darkness. If you could float near it, you might see the faintest glow, like the ember of a fire, hidden in a blanket of ash. The protostar gathers more gas, pressing inward under its own weight. It grows denser, hotter, brighter, and after millions of years of quiet collapse, the fire within finally ignites. A star is born, but there is no sound, no blaze, no explosion. The birth of a star is like the moment dawn begins, silent, inevitable, gentle, too. A star's long, peaceful middle age. Once a star begins shining, it enters the longest part of its life, a calm, steady time that can last billions of years. Our sun is in this stage now. To the star, life feels simple. Hydrogen becomes helium. Helium drifts outward. Energy flows upward from the core, and a warm, golden light drifts into space. If you could sit near the surface of a star, you would not feel fire, not in the way we understand it. You would feel pressure, motion, waves of plasma rising and sinking, like gentle tides on a bright, endless ocean. But from afar, from the perspective of the galaxy, stars simply glow. No rush, no urgency, just patient, radiant lives. Some stars burn slowly, gently sipping their fuel, and lasting trillions of years. Others burn hot and bright, using up their energy quickly, like candles in a strong breeze. But whether large or small, each star feels timeless to itself, a soft beacon in the vast, dark sea. 3. The slow swelling of old age. Eventually, after billions of years, a star begins to change. Its hydrogen, the fuel it relies on, starts to run low, and the star responds the only way it can. It expands, slowly at first, like a deep breath, then more and more, until it swells into a red giant. This transformation isn't violent. It's not sudden. It's more like watching a balloon inflate. Over hundreds of thousands of years, the star's outer layers soften. Its glow turns a deep, warm orange. Its surface cools lightly, like embers settling after a long, bright fire. If you could watch this stage play out in real time, you'd barely notice the change. Just a gentle brightening, a soft reddening, a slow, graceful expansion. Inside, the star rearranges its structure, layer upon layer of new elements forming, as gravity and pressure continue their slow dance. This is stellar old age, a period of reflection, of gentle unraveling, of quiet transformation. 4. The most peaceful farewell. A white dwarf. For many stars, including stars like our sun, their ending is not explosive. It is peaceful. A gentle breeze begins to push the outer layers away, softly, softly, until the star sheds its atmosphere, like a dandelion releasing its seeds. What remains is a glowing core, a small, dense, white-hot pearl of light, called a white dwarf. A white dwarf is no longer creating energy. It simply cools, very slowly, for billions and billions of years. If you could hold one in your hands, not possible, of course, but imagine, it would be no larger than Earth, yet heavier than an entire mountain, and yet it shines softly, like a fading ember that refuses to fully go out. These white dwarfs drift across the galaxy, like quiet, ancient spirits, the last whisper of the stars they once were. Eventually, after unimaginable stretches of time, they cool into dark, quiet remnants, known as black dwarfs. But the universe is not old enough for even one black dwarf to exist yet. Every white dwarf you see is still quietly glowing, somewhere in the cosmic night. 5. For the brightest stars, a louder goodbye. Not all stars end gently. The largest ones, the giants among giants, burn through their fuel quickly, and when the end comes, it arrives with great force. But even this force, when seen from the scale of the galaxy, is simply another step in the slow breathing of the cosmos. These massive stars collapse inward, then rebound outward, in a brilliant supernova. It is bright, dazzling, but brief. For a moment, the light of one dying star, can outshine an entire galaxy. But remember, this moment is tiny, a flash, a cosmic blink. Soon, the explosion fades, leaving behind either a dense neutron star or a black hole, and the material the star once held is scattered back into space, where it becomes the building blocks of new stars, new planets, and someday, even life. It's a cycle of renewal, a cosmic breathing in and out. 6. Stars, as the universe's memory keepers. Every star keeps a record, not in words, but in elements, the substances they create in their cores. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, and so on, step by step, up the ladder of the periodic table. By the time a star dies, it has created many of the elements that make planets solid, that build atmospheres, that form oceans, that enable life. The calcium in your teeth, the iron in your bloodstream, the oxygen you breathe, the carbon in every cell of your body, all of it came from stars. You are made of stardust, not in a poetic way, but in a literal, physical way. The universe recycled itself into you, and those same elements will one day recycle again into new stars, new worlds, new forms of life that we cannot even imagine. 7. Drift with the cosmic tide. Let your breathing slow now, in and out, matching the rhythm of the stars themselves. Their lives are not frantic, not chaotic. They are steady, predictable, calm. Even their deaths, whether quiet or bright, are part of a soft cosmic cycle that repeats endlessly. Stars are the quiet architects of the universe. They take darkness and fill it with gentle light. They take emptiness and turn it into chemistry. They take time and transform it into warmth. Tonight, as you imagine these slow-moving processes, remember that you are part of the same rhythm, made of the same material, bound to the same galaxy, that hums softly in the background of every night. You are part of this story, a quiet participant in the long, patient life of the cosmos. Part 6. The soft drift of cosmic dust and the hidden weave of the universe. Take a deep breath, feel the coolness of the inhale, and the warm, gentle fall of the exhale. Let the night settle around you like a blanket of dark velvet, because now we drift even deeper into the quiet story of the universe, into the soft motion of cosmic dust, and the invisible threads that bind everything together. Tonight, we explore the tiny particles that shape galaxies, the unseen forces that guide their dance, and the delicate, whisper-like structures that hold the universe in place. Settle in, slow down, and float with me into the peaceful stillness of Part VI. 1. Dust, the tiny seeds of everything. When most people hear the word dust, they think of something small, insignificant, floating lazily in a sunbeam. But cosmic dust is different. It is older, colder, more mysterious. Cosmic dust is made of the tiniest fragments of stars, shards of carbon, silicate crystals, grains of iron and oxygen, that once belonged to stars long forgotten. These grains drift through the galaxy, like soft, dark snowflakes. Each one smaller than a whisper, each one older than imagination itself. If you held one in your hand, if such a thing were possible, it would be invisible, just a speck, a nothing. But gather enough of these specks, let them collect slowly, over millions of quiet years, and they begin to build clouds, planets, moons, oceans, life. Cosmic dust is the gentle foundation upon which everything solid in the universe is built. The earth beneath your feet, the air you breathe, the water that runs through your cells, all of it began as dust, drifting through the Milky Way. You began as dust. Every story of life does, too. Dust clouds, the universe's softest shadows, When cosmic dust gathers in large numbers, it forms enormous clouds, dark, quiet silhouettes that block the starlight behind them. If you look up at the Milky Way on a clear night, you'll see dark lanes winding through the glowing river of stars. Those are dust clouds, cold, gentle shadows, draped across the galaxy like silk. These clouds are not empty, far from it. They are full of potential. Deep inside them, dust mingles with cold hydrogen gas. The temperature drops to unimaginable lows, and slowly, gravity begins its quiet work. Here, hidden from the light of passing stars, the universe knits together the seeds of new suns. Clouds that look like emptiness are actually nurseries, wombs for stars not yet born. In these places, the night is thick and ancient. If you could drift inside one, your vision would fade to black. Your surroundings would become silent. You would feel wrapped in the deepest stillness you've ever known. But even in that silence, a slow shift is happening. Gas is gathering. Dust is settling. Light is preparing to awaken. The universe creates stars inside its darkest places. 3. The gentle collapse of a cloud. Star formation doesn't begin with heat. It begins with collapse, a slow contracting of a cloud that can span dozens of light years. Gravity pulls here, tugs there, drawing material inward, so patiently that thousands of human generations could pass before any noticeable change appears. Inside the cloud, the density increases, temperature rises by fractions. The darkness grows thicker, as if preparing for the spark. And then, deep within the silent cocoon, a tiny point of warmth forms, a subtle glow, like the first ember of a winter fire. The cloud continues to shrink. The center grows hotter. Pressure builds. Layer upon layer of material falls inward, like snow drifting from the sky. And after millions of years of this quiet, steady contraction, a star ignites. This is the universe's slowest exhale. 4. Cosmic dust and the origins of worlds. But stars are only half the story. Around newborn stars, disks of dust begin to swirl, thin, delicate rings, glowing faintly in the young starlight. These disks are peaceful, gentle structures, so wide that billions of Earths could fit across them. Inside these disks, dust grains collide, not violently, but softly, like two snowflakes brushing together. They stick, they join, they grow, 1 micrometer at a time, 1 millimeter at a time, one slow, drifting collision at a time. Over millions of years, these dust grains form pebbles, then rocks, then boulders, then worlds. Planets are not born in explosions. They are born in stillness. They form in the quiet spinning of a disk, in the gentle settling of material, in the slow, steady accumulation of countless tiny pieces that once drifted alone in the darkness. When you stand on the earth and feel the firmness beneath your feet, you are standing on dust that slowly joined hands over unimaginable spans of time to become the ground you know today. 5. The invisible threads, gravity and dark matter. Now we drift beyond the scale of dust and stars, and into something quieter still, something unseen, because the universe is not held together by light, or by matter, or by dust. It is held together by gravity, a silent, patient force that never sleeps. Gravity is the soft hand that gathers clouds into stars, the quiet pull that forms galaxies, the gentle curve that shapes the path of moons and planets. But gravity has a secret partner, one even more mysterious than the dust we cannot see. Dark matter. It does not glow. It does not shine. It does not reflect light. It cannot be touched, or held, or measured directly. But it is everywhere. It surrounds every galaxy, like a soft, invisible halo. It threads between galaxy clusters, like strands of silk. In a cosmic web, dark matter is the hidden skeleton of the universe, the framework that holds everything in place. Without it, the Milky Way's spinning arms would fly apart like sparks from a fire. Galaxy clusters would drift away, like leaves in the wind. Stars would wander alone. In the cold emptiness of space, dark matter keeps the universe whole, quietly, patiently, without ever revealing its form. 6. The cosmic web, the universe's whispered architecture. Now let's drift even further, past galaxies, past clusters, past the small glow of everything familiar. At the largest scale, the universe does not look random. It forms a vast network, a delicate web of filaments and voids. Imagine a spider web, stretching across unimaginable distances, threads connecting clusters of galaxies, rivers of dark matter guiding the flow of material, empty spaces like soft hollows between the strands. This is the cosmic web. When viewed from above, if such a vantage point existed, it would look like glowing threads against a backdrop of deep night. Each bright knot would be a cluster of galaxies, each line a corridor of dark matter and stars, each empty pocket a quiet region where very little exists. The universe has shape, not rigid, not fixed, but beautiful and softly structured. It expands, it stretches, but its threads remain, and we, on our small blue world, are tucked gently into one of these threads, like a single grain of dust, woven into a vast cosmic tapestry. 7. The soft drift towards stillness. As we drift through the final moments of this chapter, let your breath move slowly, in a rhythm as old as the universe itself. In and out, like the pulse of a quiet star. Dust drifts through galaxies, stars form in the dark, planets slowly grow from tiny grains. Gravity gathers everything into soft, orderly motion, and the cosmic web stretches across the night, like a whispered memory. Nothing in the universe is rushed. Nothing is impatient. Everything unfolds at the natural pace of existence, calm, steady, inevitable. You are part of this rhythm, part of this gentle unfolding, part of the dust, and the gravity, and the quiet weaving of time and space. Tonight, as you listen, let that truth settle softly in your mind. You belong to the universe, and the universe belongs to you. Part 7. The gentle flow of galactic rivers and the slow migration of stars. Settle in once more. Feel the weight of your body gently sinking, as if gravity itself were cradling you with a soft, steady hand. The night is wide, the galaxy is patient, and in this chapter, we float deeper into the quiet currents that move stars across the Milky Way, like glowing leaves, drifting through a cosmic river. Close your eyes, if you'd like. Let your breath grow long and slow, because tonight, we explore the smooth, ancient motion of stars, the subtle tides that guide them, and the serene pathways carved through the galaxy over billions of years. 1. The galaxy isn't still, it flows. When we look at the night sky, the stars appear fixed and unmoving, quiet, anchored, but this stillness is an illusion. Every star, including the sun, is drifting through the galaxy at hundreds of kilometers per second. Yet the Milky Way is so vast, so impossibly spacious, that their motion feels frozen, like watching glaciers move from a distance far too great. Imagine a river that flows so slowly. You can't see the water move at all, but return after a lifetime, and the shoreline has shifted. The galaxy is that river. Its stars follow smooth, graceful orbits around the center, not perfect circles, but soft elliptical paths, like ripples gently expanding from a stone that was thrown billions of years ago. And every star, from the smallest red dwarf to the brightest giant, feels the same subtle pull of the galactic tide. 2. The sun's quiet journey through the galaxy. Our own sun is not standing still. It is drifting, slowly, patiently, softly. Right now, the sun is moving around the Milky Way at roughly 220 kilometers per second. That sounds fast, and it is. But the galaxy is so wide that one full orbit takes about 230 million years. The last time the sun finished a full lap, Earth had only just begun, forming its earliest forests. And when the sun completes its next lap, the continents will have shifted, climates will have changed, and humanity will be a distant memory, or something entirely new. From our small vantage point, the sun feels constant, reliable, motionless. But in the grand picture, it's gliding through the galaxy, like a lantern on a dark, gentle river. 3. Spiral arms. The galaxy's slow-moving waves. Many imagine the Milky Way's spiral arms as solid structures, like fixed pathways winding through space. But spiral arms aren't made of specific stars. They're more like waves, patterns that move through the galaxy, the way sound waves move through air. As stars orbit the Milky Way, they drift in and out of these arms, over millions of years. It's like walking through a field of tall grass. You move forward, but the waves of grass move differently, swaying, bending, shifting with the wind. Stars behave the same way. The spiral arms are areas where gas and dust are slightly denser, encouraging the birth of new stars. So they appear brighter, fuller, and more defined. But individual stars don't stay in the arms forever. They pass through, linger for a time, then drift away into quieter regions of the galaxy. The Milky Way breathes in spiral patterns, a slow, majestic motion that takes hundreds of millions of years for each rise and fall. 4. Stellar streams. The Milky Way's gentle tides. Beyond the spiral arms, the galaxy contains delicate rivers of stars, called stellar streams. These streams form when small galaxies wander too close to the immense gravity of the Milky Way. Slowly, not violently, not suddenly, they are pulled apart. Their stars stretch into long, wispy trails that wrap around the galaxy. In quiet arcs, imagine a handful of glitter, slowly released into still water. The particles drift outward in long, smooth lines. That is what a stellar stream looks like. The stars within a stream move together for billions of years, held in a shared memory of the small galaxy they once belonged to. Some streams circle the galaxy like ribbons. Others drape across the outer halo, like trails of distant, glowing smoke. If you could stand on a lonely world, inside one of these streams, your night sky would be filled with more stars than you could count, not scattered randomly, but arranged in long, luminous rivers, flowing across the darkness. 5. The galactic halo, a soft realm of solitary stars. Surrounding the Milky Way is a vast, spherical region known as the galactic halo. This is not a bright place. It is sparse, quiet, filled with ancient stars that drift slowly through the dark. These stars are old, so old that many were born when the universe itself was still young and bright. Some are among the first stars ever formed. They wander the halo like elderly travelers on a long and peaceful journey. From afar, their orbits seem random, like soft, drifting snow carried by swirling winds. But each star in the halo has a story. Some were formed inside the Milky Way, others were captured from small galaxies that passed too close, and many belong to stellar streams, stretching across the outskirts, like faint cosmic highways. The halo is the quietest part of the galaxy, a place where time seems almost frozen, where motion is slow, where every star feels like an ancient whisper. 6. The soft gravitational dance between stars. Even though stars are far apart, so far that they rarely come close enough to disturb each other, the galaxy's overall gravity, creates subtle tides that guide their motion. These tides are delicate, almost impossible to feel on human timescales, but over millions of years, they can gently bend a star's orbit, nudging it inward or outward, changing its path by small degrees that grow more meaningful with time. It is a cosmic waltz, graceful, unhurried, almost meditative. Sometimes, stars pass close enough to influence each other directly, not violently, but softly, like two dancers brushing hands. As they drift past one another, a small gravitational pull here, a gentle shift there, and the stars continue onward. The galaxy is full of these silent encounters, tiny adjustments that add up to the slow choreography we observe today. 7. The slow drift of star clusters. Many stars begin life inside star clusters, groups of hundreds or thousands of newborn suns formed within the same cloud. At first, these clusters are tight-knit. Their stars circle one another in a soft, glowing embrace. But over time, gravity from the surrounding galaxy tugs at them, pulling gently, gradually, persistently. After hundreds of millions of years, most clusters drift apart. Their stars scatter into the galaxy, like petals carried on the wind. Yet these siblings, though separated by vast distances, continue to move through space, with similar motion, a lingering echo of their shared origin. Astronomers call these groups moving families or stellar associations. They are cosmic siblings who have wandered far from home, but still carry the memory of where they began. Even the Sun belongs to a family like this, a group of long dispersed stars that once shared a cradle in the quiet darkness of a long vanished cloud. 8. Drift with the galactic current. As we reach the quiet end of part 7, let your breathing soften again. Feel the stillness settle into your shoulders, your chest, your hands. Stars are drifting all around us, not in straight lines, not in hurried paths, but in soft, swirling motions that take hundreds of millions of years. The sun is drifting, the halo is drifting, stellar streams are drifting, the spiral arms are drifting. Everything in the galaxy moves like water, slow, patient, guided by the invisible pull of gravity and the even deeper presence of dark matter. Nothing is still, nothing is lost. Everything is always in motion, yet always at peace. As you rest here, remember that you, too, are part of this gentle drifting. Your atoms were shaped by stars, moved by cosmic tides, guided by forces older than time itself. You are part of the galaxy's slow breath, part of its memory, part of its endless, quiet flow. Part 8. The quiet geometry of hidden dimensions. As we continue our slow descent through the mysteries of existence, let your breathing settle into something loose and effortless, like a soft tide rolling across a quiet shoreline. The universe is vast, and its stories stretch far beyond the boundaries of our familiar three-dimensional world. Tonight, we drift into a realm that is as subtle as moonlight and as old as the first trembling second of creation. The realm of hidden dimensions, curled and folded into the fabric of reality like secret rooms just out of sight. For most of human history, space seemed beautifully simple: forward and back, left and right, up and down, and time flowing gently in one direction. 4 dimensions, clean, comforting, stable. But nature, as it turns out, is rarely content with simplicity. Underneath the bright surface of the world, beneath particles, beneath forces, beneath even space-time itself, something far stranger may be taking shape. A network of extra dimensions, tightly wound and hidden away, shaping every particle's identity in ways we can't yet see. Physicists call this possibility extra-dimensional geometry, and though it sounds like science fiction, it may hold the key to understanding why matter behaves the way it does. why particles have mass, why the fundamental forces have their strengths, and why the universe chose the delicate asymmetry that allowed matter to survive over antimatter. So let your mind soften and imagine this. The universe is not a flat sheet stretched across emptiness, but a vast and intricate tapestry woven from many threads, some wide and familiar, some narrow and unseen. These hidden threads might curl so tightly that no human eye could ever glimpse them. Yet their quiet presence shapes everything we know. 1. Where dimensions hide. The Calabi-Yau whisper. In certain branches of theoretical physics, especially string theory, these extra dimensions are not just hypothetical embellishments, they are essential. The equations that describe vibrating strings, tiny entities believed by some to be the most fundamental building blocks of reality, refuse to work unless space has more than 4 dimensions. Not 5, not 6, but 10 or 11. Most of these dimensions, however, are curled up in elegant, intricate shapes known as Calabi-Yau, manifolds, tiny geometric chambers so minuscule that even our most powerful microscopes and particle colliders cannot open them. Yet these shapes determine how strings vibrate, and therefore dictate what particles exist and how they behave. A small change in that hidden geometry would change everything. Your atoms, your chemistry, the warmth of stars, the stability of matter itself. Imagine these dimensions as delicate origami folds, not visible from a distance, but essential for the structure of the whole. Every particle's mass, every charge, every interaction may be a faint echo of the geometry humming quietly in those hidden spaces. If the geometry had shifted in the earliest moments of the universe, even slightly, matter and antimatter may have been born in different proportions. One fold could determine the mass of a quark, another fold the strength of a force, another fold the stability of a proton, and somewhere deep within that structure may lie the reason matter survived. 2. A symphony played across invisible directions. If extra dimensions exist, they are not silent. They vibrate. They resonate. They interact with the large dimensions in ways we might one day detect. Some physicists imagine the early universe humming like a cosmic instrument, with each dimension contributing a tone. You might picture it as a multi-dimensional harp, strings plucked by the expansion of space itself. In some dimensions, the vibrations faded quickly. In others, they lingered, imprinting themselves onto the particles forming in that first hot plasma. Matter and antimatter might have been born from these vibrations, like harmonics rising from the pluck of a string. And perhaps, just perhaps, one of these hidden dimensions vibrated in a way that ever so slightly favored matter. Maybe the geometry twisted just so. Maybe a tiny ripple passed through one dimension but not its mirror. Maybe the expansion of space stretched one fold faster than another. Tiny differences like these could easily create the 1 in a billion imbalance that made everything possible. In this way, the universe didn't decide to prefer matter. It simply expressed the resonance of its own hidden architecture. 3. Shadows of higher worlds. The brain picture. Some physicists offer a different vision, one even more dreamlike. Our universe may be a kind of floating sheet, a membrane, or brain, suspended in a higher dimensional space. Just as a 2-dimensional sheet can ripple within a 3-dimensional room, our 3-dimensional universe might be drifting and waving inside a much larger, multi-dimensional arena. If this is true, then matter and antimatter might have been affected by forces leaking into or out of our brain. Perhaps one side of the membrane touched a region of higher dimensional charge. Perhaps the early universe brushed lightly against a neighboring brain. Perhaps an asymmetry was stamped onto our cosmos like a faint fingerprint from outside. And in some models, antimatter may not have vanished. It may have been pulled or pushed into another brain entirely. Imagine that. A sister universe, just a hair's breadth away in higher dimensional space, filled not with matter, but with antimatter stars made of positrons, galaxies glowing with unfamiliar light, voids shaped by the opposite charge of its constituents, silent, watching, never touching. It's a poetic thought. that somewhere, so close we could almost breathe it, exists a universe that mirrors ours, but runs backwards in charge. A cosmic twin separated not by distance, but by dimensional direction. 4. The dimensional heartbeat of baryogenesis. Baryogenesis, the great imbalance between matter and antimatter, is one of the most delicate processes in the story of creation. To produce the slight excess of matter, the early universe needed just 3 ingredients. 1. Processes that treat matter and antimatter differently. 2. Interactions that violate symmetry between time-forward and time-backward motion. 3. A state far from thermal equilibrium, a kind of cosmic upheaval. Extra dimensions could provide all 3. If the hidden dimensions expanded or contracted at different rates, they would create natural asymmetries. If particles traveled through or interacted with these dimensions, their behaviors could differ ever so slightly from their antimatter twins. And the violent, boiling conditions of the early universe were perfect for amplifying tiny differences into lasting consequences. Picture the early universe as a vast bowl of swirling currents, some flowing through dimensions we know, others slipping through dimensions we can't see. If matter felt even a faint tug from a hidden direction, and antimatter did not, the balance would tip. Just a whisper, a nudge, a gentle tilt of geometry, but enough to leave a faint residue, the matter that would one day become stars, planets, and you. 5. The unseen structure beneath physics as we know it. Often, we think of physics as a neat set of rules, carefully arranged like the gears of a clock, but hidden dimensions suggest something more organic, that the rules we observe may be mere projections of a deeper, richer structure, curled up out of sight, like shadows cast on a wall, like echoes of a song played in a room we cannot enter, like ripples on the surface of a pond whose depths remain unseen. If the fundamental forces arise from the shape of hidden dimensions, then every symmetry we see is just a reflection of deeper symmetries beyond our senses. And every broken symmetry, including the one that saved matter from annihilation, may be the result of a subtle imperfection in the universe's multidimensional architecture. In this way, the universe is not merely a collection of particles obeying rules. It is a structure, a geometry, a breathing, expanding, multidimensional form whose properties ripple outward through time and space, like soft vibrations in a great cosmic shell. These hidden dimensions do not just exist, they guide, shape, sculpt, they whisper. 6. Dreams of detecting the undetectable. Even though these dimensions are tiny beyond imagining, scientists are searching for their fingerprints. Tiny deviations in gravity, unexpected patterns in the cosmic microwave background, short-lived particles that shouldn't exist in 4-dimensional physics, the energy spectrum of dark matter, ripples in space-time produced by early universe inflation. All of these may be clues, but even if we never detect them directly, extra dimensions offer something more important, a deeper way to imagine the universe, a way to perceive reality not as a flat, simple surface, but as an intricate, folded landscape filled with chambers, tunnels, twists, and curls, all too small to see but large enough to shape everything. And maybe, just maybe, these hidden spaces once guided the balance between matter and antimatter, creating the fragile asymmetry that allowed stars to shine and life to form. 7. A soft return to the visible world. As we drift back toward the familiar 3-dimensional world, let the thought settle quietly. The universe we see may be only the faintest hint of a much larger reality. Our atoms may carry the imprint of structures hidden beyond sight. Our existence may depend on the subtle curvature of invisible dimensions. Our entire cosmic history may echo the shape of spaces we will never touch. And in these hidden chambers, folded like petals deep inside the flower of space-time, may lie the answers to questions we've only just learned to ask. Why is there matter? Why is there asymmetry? Why does the universe exist at all? For now, we rest in the mystery. Let it drift around you like starlight dissolving in night air, soft, quiet, infinite, and deeply, deeply peaceful. And now, as our long, quiet journey through the mysteries of the universe comes to a gentle close, you might feel your breath slowing, your mind softening, like a lantern dimming at the end of a peaceful night. We've wandered through the earliest whispers of existence, through matter and antimatter, symmetry and its breaking, through hidden dimensions, curled like secret petals, through bubbles of the multiverse, drifting in an infinite sea, and through the delicate threads that hold reality together. And through it all, one idea rises softly, like moonlight pushing through a thin cloud, that our universe, with all its galaxies, its stars, its oceans, and its tiny beating hearts, exists because of a single, fragile imbalance, a 1 in a billion imperfection that tipped creation toward matter, toward survival, toward form. That tiny tilt allowed atoms to gather, light to ignite, and time to unfold into the long, slow story that carried you all the way here. It's humbling, isn't it? To think that everything you know, everyone you love, every breath you've ever taken, may trace its roots back to a flicker of asymmetry in the first heartbeat of the cosmos. And yet, there is something comforting in that mystery, because it reminds us that existence does not need absolute order. It does not require perfect symmetry. It does not demand certainty. Life emerges in the spaces where perfection breaks, where stillness trembles, where the universe allows itself to be just a little uneven. As you rest here now, imagine the universe as a great, drifting night sky, endless and gentle, stretching out far beyond what any eye can see. Somewhere, hidden dimensions still curl quietly beneath reality. Somewhere, other universes may be expanding with their own stories, their own physics, their own versions of matter and light. Somewhere, the echoes of the very first quarks are still humming through cosmic space, carrying the faint memory of creation. And you are part of that story too. A small, shimmering moment in a vast ocean of time, a pattern of matter that only exists because the universe chose ever so slightly to lean toward being rather than nothingness. So, as this exploration softens into silence, let your thoughts drift like slow-moving galaxies. Let the questions remain open, like windows looking out into the deep night. You don't need answers right now. You don't need certainty. The universe itself is still wondering, still unfolding, still learning what it means to exist. For now, it's enough simply to rest, to breathe, to float gently in the quiet mystery of it all. Thank you for drifting with me through this long, starlit journey. May your night be calm, your sleep deep, and your dreams filled with the soft glow of distant galaxies.